Hi students, today in this session we are going to see the remaining questions of the exemplar problems from the chapter Amines. Okay, so let's continue. So in previous video I have discussed 20 questions. I will give the link in the description box. Please follow the video. So the best method for preparing primary amines from alkyl halides without changing the number of carbon atoms in the chain is. So they are asking what method. See, Hofmann bromamide reaction. See what will happen if you take any amide, you will end up with amine, but you are losing a carbon, using a carbonyl carbon. So okay, Hofmann bromamide reaction is not the option. Yes, Gabriel thalamide reaction, as you know. So we used to treat with the sodium potassium salt of thalamide with the alkyl halide. So you can prepare the primary amine without losing any carbon. Okay, so Sandmeyer reaction, you cannot prepare any primary amine in this reaction. And reaction with ammonia, if you treat any alkyl halide with ammonia, always you will end up in the quaternary salt. You cannot stop the reaction in between because it is a very activated molecule. Okay, so the corresponding anion. Okay, so the answer is Gabriel thalamide synthesis. Which of the following compound will not undergo azo-coupling reaction with benzene diazonium chloride? First of all, what is a coupling reaction, students? See, your diazonium salt, okay, your diazonium salt is very much electrophilic in nature. So I have taken the chloride ion. Okay, so if you treat with aniline, so you know that aniline is a very much nucleophilic the ring is very much rich because of this amine, a donor. Okay, so due to this plus R effect. Okay, so its ortho and para position in the electron density will be very more. So what happens in the para position, if I draw like this, so in the para position the electron density will be more. So there will be a okay, so this anion, okay, this anion will attack this nitrogen and thereby, okay, so you will get what? You will get the para substituted. This is known as azo-coupling. Okay, so it is, since the conjugation is very more, it looks like a very red dye like that. Okay, similar things happens with phenol also. Okay, so phenol also is a electron rich ring. And what are the options they have given? Anisole also, it's more powerful than phenol. But your nitro compound, your nitrobenzene, what it is, your nitro is minus I and minus R. It's a powerful electron withdrawing group which makes the ring very much electron poor. So the azo-coupling will not take place in nitro. So next question, which of the following compound is the weakest Bronsted base? See, the Bronsted base is always proportional to the electron density on the donor atom. So preferably it is always a nitrogen and oxygen which is having the free electrons. Okay, so for donating. Okay, so in these molecules, if you see the nitrogen, all the nitrogen and oxygen has lone pair, but you see these two are, okay, the electron density will be more in these two molecules in the aliphatic system due to the R effect, due to the plus I effect of the alkyl groups. Okay, so these are very rich base. So they are asking the weakest Bronsted base. So among these two, aniline and phenol. See here the lone pairs are involved in conjugation which makes the electron density very less. But when compared to aniline and oxygen, your phenol, this is your phenol moiety. You know phenol has acidic proton, right? Acidic proton, your phenol is an acidic molecule. It donates proton rapidly when you treat with base. So how can you compare this? See, both are having the conjugated system. The lone pairs are involved in the ring system, but compared to nitrogen, oxygen has more electronegativity. So its donating capacity also decreases. So, and also see oxygen and hydrogen, here more electronegative differences there. So this makes this proton very acidic in nature. What is acidity? What is acidic in nature? If you treat with any base, immediately your phenol will lose its proton, will lose its proton and change to this conjugate base. Okay, so this is the option in which phenol is your weakest base. So the next question, among the following amines, the strongest base. So for any basicity you have to check the electron density only. So here all are nitrogen, you see. In aniline and in pyrrole, the lone pairs are involved in aromaticity, so it is not available, which make the electron density very less. So in comparing ammonia and this one, you see here this is totally unsubstituted and this is neutral. Okay, electron density is more, but when compared to this is having the tetrahydropyrrole. Okay, it is having more electron density due to the plus I effect of the alkyl chain surrounded it. So, okay, the electron density will be very more. So this is the option. The correct decreasing order of basic strength of the following species. So the basic species you must follow this. See, always the anion is more basic than the neutral and then the cation. Okay, so these two are neutral. So okay, so let's first compare this one. See, oxygen OH minus and NH2 minus. OH minus, NH2 minus. Oxygen is having more electronegativity, so it will not be more basic when compared to NH2 minus. So first most basic will be this anion NH2 and then is your OH minus. And comparing to water and ammonia, your neutral molecule again give importance to nitrogen because of its lower electronegativity, and then comes your water. Okay, so the option is first one. Which of the following should be most volatile? See, any compounds, any molecule that doesn't have any interactions, any dipoles. Okay, usually van der Waals force will be there. Okay, apart from that, if you have hydrogen bonding, if you have dipole interactions, okay, your molecule will be very much attached, very much closer to each other if these interactions exist. Okay, which makes it high boiling. Okay, if it is not there, you will be having only van der Waals force, so easily it can evaporate, easily it will boil. Okay, so this is a pure hydrocarbon. It only have van der Waals force, it doesn't have any hydrogen bonding, it doesn't have any dipole interaction. Okay, whereas you see these are amines, it has hydrogen bonding and dipole interaction and hydrogen bonding. Okay, so this is the option. So the answer is 4. So the next question, which of the following methods of preparation of amines which will not, the question is wrong here, which will not give same number of carbon atoms in the chain of amines as in the reactant. So this is nitrile actually. So any nitrile, if you treat with lithium aluminum hydride, you will get the corresponding, the carbon. Okay, the molecule is the same. And if you treat the amide, with lithium aluminum hydride, you get the same answer with the same number of carbon atoms. You know Gabriel thalamide synthesis, you will not going to lose anything. So this is your Hoffman bromamide reaction, bromine and aqueous sodium hydroxide. Please remember this, students, whenever you see bromine and sodium hydroxide, when it treats with amide, these are the keywords. Okay, so you have to think about that. So when you treat any amide with these reagents, you will lose a carbon. Okay, so this is the answer. Okay, so the next coming questions are multi-choice questions of type 2 in which more than one option is correct. Which of the following cannot be prepared using Sun-Meyer reaction? So what is Sun-Meyer reaction, students? See, for any diazonium salt, if you treat with copper salt, you will get the corresponding halogen here. So in this way you can treat the bromine also. Okay, but you cannot prepare the iodo and fluorine derivative. For iodobenzene, you have to use potassium iodide with the diazonium salt and HbF4. Okay, so the options are iodobenzene and fluorobenzene. Reduction of nitrobenzene by which the following reagent gives aniline. So this is very important. You see, the nitro can be very well converted to the corresponding aniline with a set of reagents, either tin and HCl, okay, or or iron and HCl, okay, or hydrogen palladium. Okay, so these three reagents are helpful to convert this. Which of the following species involved in the carbile amine test? See, carbile amine test is used to identify the primary amines. So what happens here? So NH2 plus, this is your carbile amine reaction in presence of potassium hydroxide. Okay, so you will get the corresponding isocyanate. You will get the corresponding, it is a foul smelling, very poisonous also. It can be, if it hydrolyzes in water, it will give the poisonous gas. Okay, so this is your carbylamine reaction. So which are involved? Chloroform and KOH and your RCN. Okay, that is a product, RNC, isocyanate. Okay, so this is a reaction. So the reagents that can be used to convert benzene diazonium chloride to benzene. This is a very important reaction, students. See, this is your diazonium chloride. Instead of this, you need to have a hydrogen here. This hydrogen comes as hydrate. So what are the source of this hydrate? So the answer is your ethanol. Here what it will do, it will oxidize. Okay, it will oxidize to this one and deliver a hydrate here. Okay, and as well as your H3PO2. Okay, this will also deliver hydrate. Okay, these two are the options, please remember. Okay, so the product of the following reactions is, see here your aniline, this is acetanilide. This is not a free aniline. Your free aniline is a very high electron rich molecule due to this donor. Whenever, if you do bromination with this aniline, always you will end up with the tribromo product. You will not stop the reaction. You will not get mono-bromo derivative. You will get only tribromo derivative. To control this, what we are going to do is, we are going to introduce an electron withdrawing group adjacent to the nitrogen by acetylation with acetic acid or acetyl chloride or acetic anhydride. Okay, so when this happens, say your lone pair will be partially involved in conjugation with this carbonyl. So this acetyl will partially pull the electrons this-ward. So the lone pair cannot enter. The lone pair entering into the benzene ring is controlled by this electron withdrawing group. So it is not available in surplus. So you will get only mono-bromo derivative. So you will get, so again due to this, only the ortho and para position will get electron rich. So you will get para-bromo, either both para substituted acetanilide and your ortho substituted acetanilide, and not your meta and not the tribromo derivative. So this is a very important reaction that where you can control, okay, the donation of the electron, the nucleophilicity of nitrogen. Okay, so the arenium ion involved in the bromination of aniline. Say aniline, for aniline, so I will write this conjugated structure so that it will be easy. Okay, so this happens. Okay, if it is going to occur in the ortho position, if it is going to occur in the ortho position, this is going to happen. Your bromine comes here. Okay, so what happens continuously? This will undergo. Okay, so here. Okay, and this one here and plus charge here. Okay, so and after hydrogen will remove from here to neutralize the charge. Okay, if this is for ortho substitution, if the para has to take place, this one and this one, so your bromine comes and sits here. Okay, so your bromine comes and sits here. So the answer, so the hydrogen obviously it is there. So what are the structures involved? It is this structure and this structure if the substitution takes place in ortho, and this one para and meta is not possible. Okay, So the next question, which of the following amines can be prepared by Gabriel synthesis? So no, to secure the time, I have written the structures already. So I have already told you only primary amines can be prepared, not your secondary amine, aromatic amines or tertiary amine. Okay. So here your aniline cannot be prepared since it is an aromatic amine, and your N-methyl benzyl amine cannot be prepared because it is a secondary amine. Okay, so it is a secondary amine. It is surrounded by 2 carbon atoms. Okay, so here your isobutylamine is a primary amine and your 2-phenyl ethyl amine is a primary amine. So these 2 can be prepared. Okay, so which of the following reactions are correct? You see, when you see this is a substitution reaction. Okay, your nitrogen attacks this carbon, your chlorine goes out. Okay, so this is your nucleophilic substitution reaction. This is possible. And alcoholic KOH is the aqueous KOH. Aqueous KOH is a reagent for substitution. So in this reaction, what is the expected product is? Your expected product is this one and not the elimination. So this is wrong. Okay, and this one cyclohexyl chloride, alcoholic KOH. Okay, elimination has taken place. This is a right reaction and this is not the right reaction. So the next question, under which of the following reaction conditions aniline gives para-nitro derivative as the major product? I told you aniline is a very electron rich molecule. If it undergoes nitration, it will give you trinitro derivative only. So to control that, we have to introduce, as I told you before, we have to introduce an acetyl group. For that, what we have to follow? There are 2 reagents. You see, aniline first must undergo acetylation to form this one, then only it can undergo a controlled reaction. So here acetyl chloride in presence of pyridine. Okay, so here the lone pair attacks this carbonyl, okay, and chlorine goes out, and this use of pyridine is to hold the HCl that has been formed. Okay, so by this you can form this acetanilide, then you can treat with the concentrated HNO3 and H2SO4. This is the reagent for giving the NO2 plus species. Okay, so thereby after this, thereby you will get the para product exclusively. You will also get the ortho product, but this is major due to the steric factors. Okay, and another reagent is not only you can use the acetyl chloride, you can always use the acetic anhydride. In this, the lone pair attacks this carbonyl, okay, and this the acetyl group. Okay, the acid group goes out. Okay, so here also, then if you treat with the nitration mixture to para, you will get the para derivatives. Okay, exclusively para derivative, and you can avoid the tribromination. Okay, so the answer is first one and the second one. Okay, which of the following reactions belong to electrophilic aromatic substitution reactions? See, bromination of acetanilide, yes, is bromine. Here bromine ion is the species, and coupling reaction of aryl diazonium salt. Okay, here also I told you this is electrophilic in nature. I told you this species is electrophilic in nature, and diazotization of aniline or not these 2. Okay, these 2. Okay, thanks for watching, students. If you feel it worthy, please share along with your friends. Thank you.